All right, so I'm Lee Scoggins from the Absolute Sound, and today we have had the honor of getting a tour of the factory. It's a very impressive facility here. We've seen a lot of really cool products. We've heard those cool products, and it's just been great to be here. It's my first time in the Pacific Northwest. And we've had Robert and Kaylin talk about some of the technology and the products, but I kind of wanted to take an opportunity to talk to Grant Samuelson, who's here, and ask him some questions about maybe more of the business side of Shunyata research. And maybe to kick things off, can Grant, again, thanks for inviting us, but
Sure.
would you like to tell us sort of how you came to be part of the Shunyata team here? There's a real sort of family feeling about the place, and how did you first get involved with Kaylin?
Yeah, so it really is a small family business. That's how it got its start. I met Kaylin in 1998, late 98. I was writing reviews for Soundstage magazine. My full-time job was in mental health. I worked in maximum security mental health in Madison, Wisconsin.
Okay.
And I came across these unique power chords that were sent to me to review. And at the time, back in the late 90s, there was a lot of skepticism about whether things in the power realm belonged in high-end audio at all. I think there are still some whispers about that around the edges of high-end audio, about the role that power plays in high-end music reproduction or even high-end recorded sound. And so we're still fighting those battles a little bit here and there, but largely I think there's a growing acceptance of the electrical system, part of a high-end music system being one of the most legitimate foundational aspects of performance in a music system. So back then, when I was sent the power chords, my first impression was so profound that I took the time to pick up the phone and call the designer, Kaylin. At the time, he was working out of his condo in Port Ludlow with just his mother and his wife, and he was building one power chord at a time. I became interested in the process that he was following, and the response of my system to those power chords was so unique that I wanted to know everything I could about how they were made, what his background was, and so we got to know one another quite well over the course of the next year. And he eventually asked me to come be part of the company that he was hoping to build as the sales lead for the company. So in the year 2000, I formally started working for Shunyata Research, left my day job in mental health, and left my hobby writing gig for Soundstage magazine, and became a full-time part of Shunyata. So it took us a while, but we eventually moved out of Kaylin's condo and into a facility. But the early years were very challenging because of the suspect role that many felt that power chords played in a high-end audio system. So,
how did you overcome those challenges then? What was the secret there?
Well, we overcame those challenges by continuing to define why power chords can make a difference, what role they play as part of a component. For example, the understanding back then was that the power chord was the end of a long chain of electrical service, and it was the last 6 feet of electrical service before power reached a component. And as such, really shouldn't play a significant role in how the performance of a sound system would be affected. But Kaylin turned that around. The real purpose of a power chord is as an extension of the primary winding in a power supply. So a power chord can either act as an antenna for the high frequency noise that's constantly swirling around the system and pick up that noise and create interference, and distortion as part of that chain, or it can act as a silent pathway for those first few feet of outside of the component leading from the power supply. So if you look at a power cord from the perspective of a component, it really is the first 6 feet of electrical wiring that the component power supply sees, technically. And from that perspective, it takes on a far greater importance than just being the last leg of miles of wire leading up to a component. And then we started putting the products in front of key people. We very early on, I think it was 2003, the mastering and recording engineers and David Gilmour himself were reading Hi-Fi Plus, and we had a review show up in Hi-Fi Plus. And so the principals of Astoria Studio in the UK, the remaining part of Pink Floyd, became very interested in what we did, how we did it. Since the beginning, we'd written quite a bit about how power chords work, why they were important, and that gained a lot of resonance with some of the recording engineers back then. So they invited us to loan them some product to test in their mastering systems. And the results that they got were so profound that they immediately purchased a large quantity of not only our power chords, but I think back in 2003, we had our original Hydra system. And they became enormous protagonists for those products. So much so that they called all the different mastering engineers that they knew, mastering people at Skywalker Sound, James Guthrie, Alan Parsons, other mastering and recording professionals. I know they contacted Real World Studios where Peter Gabriel recorded, and other people in the studio industry, just out of not just benevolence and wanting to help us, but because they felt that they'd discovered something very significant that would help the mastering and recording process take the next step in terms of the potential resolution in high-end recording and mastering. So that got us more opportunities. We got an opportunity to loan some products to James Guthrie, which at the time was remastering Dark Side of the Moon for SACD.
A great mastering, I might add.
Yeah, it was a tremendous project. James explained what he was doing to us and how highly calibrated his system was, and that he didn't expect to hear much of a difference when he added our products, but that he'd heard good things about us from the guys in the UK at Astoria, and so he was willing to give it a try. There was a great deal of skepticism that went with that, so I had to, as I've done every time we've gained an opportunity, the first thing you have to do is give them a plausible explanation as to why the product would work and why they should spend their time and effort to try it.
Yeah.
James' results, as he reported to us, were so profound that he thought it was one of the most important discoveries that he'd made in the last 10 years of working in mastering. And the executives from Sony Music, at the time, the SACD release of Dark Side of the Moon, they were really putting all of their effort and money into promoting it. So the executives from Sony Music in Japan came over to preside over the finishing touches that he was putting on the SACD remaster. And instead of detailing to the executives the great work he had done and different aspects of the recording that were important to him, James took the time to do a demonstration for the executives of the replay system with our power chords and then without our power chords. The reason I remember that so vividly is that after the executives had gone back to Japan, James called me to tell me that he'd given away these expensive power chords that he'd purchased from us, and that he needed us to send him, a number of them again to refit his system. And I remember saying to him at the time, James, why did you do that? Those were really expensive power chords. And he said, well, because I think they'll have a good experience. And they were very impressed at the demonstration I did. And literally, I think it was a month later that our Japanese distributor contacted us and asked me, who did I know at Sony Music? And I came up empty. I could no longer recall that he had done that. And he said, well, for somebody there wants to buy about 30 of your most expensive power chords. And that's when the light went on in my head. And I called James, of course, to thank him profusely for the opportunity. And so that was, I think, the beginning of our opportunities in high-end professional recording and studio work. Because from there, almost within, I'd say, a few months, we got another opportunity. The principals of Skywalker Sound contacted us and said, hey, we heard from the guys at Astoria, because they both used the big Neve 88 panel. So they had, and a lot of these top-end mastering people, top-end studios, they all talk to one another constantly. They share ideas, they share discoveries, and both James Guthrie and the guys at Astoria had shared with Skywalker just how influential our electrical systems were in their products. And in fact, at the time, Skywalker was dealing with some hum and buzz problems, some sound problems of their own. So they contacted us and asked us to visit and kind of give them a demonstration of how the products work.
And my understanding is you've actually also are playing a little bit of an expert role now in terms of solving some of these noise problems that recording studios have, even though it may not directly lead to something directly beneficial to Shunyata, but y'all have sort of developed a little bit of a reputation for having some expertise in this area.
Right. Well, Kalen's background, he's a former military scientist, but his background is in electrical systems. His father is an electrician, his two sisters are electricians, and so he comes from that side of the family. So basic electrical function and system noise were a principal skill set that he brought into this work. So we do spend quite a bit of time trying to solve noise. We do that in medical now as well, in terms of consulting, solving noise problems in heart surgery labs.
Tell us a little bit about that. I know you've got this medical imaging business. How did that come about?
Well, similar to, it's almost a carbon copy of the opportunities that we gained in the recording industry, which is there was a product champion that emerged. It happened to be a surgeon in Minneapolis that was also an audiophile. So there were some cross purposes there.
Good.
And he was dealing with noise that was interfering with the resolution of these low-level heart signals. And he could not solve this problem, and he knew many other electrophysiologists that were having the same problem he was having. So he was reaching out, just grasping at straws, trying to solve these issues that were really impacting how long his procedures would last. They were impacting how much of a benefit the patient would get from the procedure, and they were impacting how long the patient would be able to function at a high level without having to come back to have another procedure. So that it limited the efficacy of the procedure and limited the amount of time that they'd have during the day, the number of procedures they could do, because they were spending more time troubleshooting noise in the lab during a procedure, saying, oh my gosh, we can't see the heart signal that well. We've got to go over here, go over there, and try to solve that noise problem, not really having a real idea of what was causing those issues. And so he carried some of our products into the lab and noticed an immediate reduction in noise, and thus contacted us to ask what other solutions we could bring into his lab that might make a difference. And that was the start of it. Probably it was 2014 at the time, maybe just going into 2015. And just as with the recording industry, word tended to spread like wildfire because of the success he'd had. He went from having difficulty reading heart signals to having the most immaculate resolution that he'd ever seen. In fact, in one of his, he wrote a couple of papers about it and detailed the results that he'd gotten. These are available on our medical website. And of course, he called a lot of other influential electrophysiologists, and then introduced us to a Johnson & Johnson company that manufactures a lot of the hardware that's used in these electrophysiology labs, to let them know that they'd come up with a potential solution to a lot of the noise problems they were having in labs.
So you found an adjacent market that has gotten real benefits from technology you developed for high-end audio. Have you learned things along the way that is also translated back into the consumer audio side of the business?
It's really confirmed the idea that we've had from the beginning, that because all of these labs that I went into and all of the studios that I've gone into already had some form of what they called noise reduction or protection from grid-related noise from getting to their electronics. And so both of these industries were dealing with noise problems that they perceived were coming from outside the system. And yet they already had transformers or chokes or products that used coils to block the ingress of noise into the studio or into the operating theater, and trying to prevent that from interfering with low-level signals, whether it be in recording or in heart surgery. And in both cases, the efficacy of our products proved two things. One, that it's an antiquated notion that noise coming from outside is the primary threat to resolution. It's not. It's actually the noise that's generated by the electronics themselves within the system. It's proximally generated noise that's creating all the challenges for the ultimate resolution of signals, whether they be in audio or in visual, in the case of medical, because what they're dealing with is visual resolution of the heart image or visual resolution of the heart signal. And in both cases, replacing transformer-based solutions with our systems that work that focus on filtering and eliminating the proximally generated noise. A good anecdote would be to say that in medical they have catheter pumps, they have radio frequency generators, they have all manner of electronics all crowded around the patient, right? They've got warm air blowers to keep the patient warm. They've got ultrasound. They've got radiology right there in the room.
That must generate a ton of noise.
So yes, an incredible cacophony of noise that exists in these labs. Even noise that would dwarf that's generated within recording systems. And because our products are focused on isolating the different footprints of noise that exist in a system, whether it's from the generator, the hot air blower, the ultrasound, or the radiology tubes that you could find in these labs, they isolated all that noise and kept it separate from the patient interface unit, which was the unit that is tasked with resolving the patient's heart signals. So you've got this one unit that sits in the middle of what's often a movable boom, and it's surrounded, literally surrounded by noise-producing So the analog in audio would be having all this digital architecture in a system, transports, upsamplers, clocks, switches, all surrounding the poor little DAC, and the preamp and the amplifiers that are outputting an analog signal. So you've got this war within the system between really pernicious noise-producing electronics that produce noise that go high into the gigahertz range and that are interfering with the reproduction of these very delicate analog signals and the propagation of that analog signal through the rest of the chain. So the similarity is really striking, except, at least in high-end audio, we all have kind of by now in 2022 the concept that noise is bad and that you want to try and avoid it or eliminate it if you've got it.
Absolutely.
And you need a lot of tools to do that in some cases.
Yep.
And the more of those tools that you deploy, whether they're really high-end electronics that have super overbuilt power supplies, or you've got this terrific electrical system, such as the ones that we make, that are going to isolate the noise that the electronics are sharing amongst each other. We call it component-to-component noise isolation. And we do an extraordinary job of that, as evidenced by the before and after heart signals that you look at on our medical site, because you can see the heart signal in the system prior to us being there that is very hard to discern amongst the noise that's riding on that signal. And then the very next screen after you've deployed our products into the system, which is completely clean of any noise.
Yeah, you guys are starting to make the job of the skeptic incredibly difficult, because when you can visualize that noise, it becomes more obvious. It's less open to attack. You guys have sort of, I think one of the things that I find is unique about Shunyata is you've always developed measurements and been able to measure the impact of your products, and that measurement technology has improved over time, such as the DT CD, but visually kind of really spells it out, I think, in some ways.
Well, we've always, for the last 15 years, and with the advent of DTCD, which is a way, the big difference between a medical system and a high-end audio system is that a high-end audio system, many of the components in a high-end audio system act like dynamic engines in the way that they're pulling current, because they're trying to reproduce a dynamic music signal that can scale from quiet to loud in a millisecond. And so these electronics are hypersensitive to the efficiency with which the full wave bridge rectifiers are receiving peak current energy, and they're pulling off the top and the bottom of the sine wave. Whereas in medical, most of the electronics in medical are relatively, in terms of the dynamics of current, fairly inert. So they're not concerned about the dynamics of current in medical, they're only concerned about isolating noise. So we can actually really apply the full boat of noise reduction technologies in medical, whereas in audio, we have to spend more money on the build out of products in audio, because you have to consider the efficiency of dynamic current getting from point A to point B being the power supply, and so we have to consider building all of the connectors on the power cords out of solid copper, the outlets on the power distributors out of solid copper. You've got to think of a symmetry of metals, maybe keeping all your metals the same, so you really have as few points of impedance along the path of current going to electronic systems. So there's actually quite a bit more customization, parts customization involved in high-end building for high-end audio. So the components can get quite expensive, because at least to achieve the optimal performance in high-end audio or in mastering and recording systems, because they have playback systems too with which they test their pressings, you've really got to spend money to make sure that you're getting the dynamics out of the performance, because sound is all about, it really starts and ends with the realistic timing and dynamics in sound. And so that's been kind of the ongoing development of our products has been following that path from the time that Kalin was able to measure the impulse, the efficiency of impulse current, and then begin to manipulate our parts and materials to serve that master, to serve that purpose of transmitting dynamic current.
Yeah.
That's the baseline, and then after that you come in over the top with all of your noise reduction methods and try to isolate the noise that the electronics are sharing amongst each other in the system.
And now it seems like you guys have taken it, maybe the next logical thing is around grounding.
Mm-hmm.
You've got this new Altaira product, which I've tried in my own system and have gotten great results.
Mm-hmm.
But can you talk a little bit about Altaira and how you're launching that and what makes it different and what are some of the challenges around introducing people to that, if you will, new foundational element?
Yeah, well, you know, it's almost as if at every step since our company's inception, we've been taking on these old sawhorses where people, you know, the skeptics reign, and they will say, well, that can't make a difference, and they usually say that without any context of their own, right?
Yeah.
No practical experience whatsoever. They're just sure it can't work because they either heard somebody say that before, or they've got some kind of junior engineering degree that tells them that this can't make a difference. And you know, I personally was against the Altaira grounding system in the very beginning, simply because it requires special attention to apply it in terms of a commercial launch, to make it easy for vendors to demonstrate it to customers. It's you know, it's a heavy lift because there are many parts that are at play here that have to all come together to create a whole. And but you know, science always wins, and Kalin's unique understanding of the background of grounding going all the way back to the 50s, and what the main cause of remaining distortion is in systems. He understood, he intuited that if you applied a grounding system that would help eliminate that radio frequency interference and electromagnetic interference that rides on signal grounds, because inside components you've got a lot of circuits and you've got a power supply that are all radiating noise energy. And some of that energy is residual energy that rides on the metal chassis of electronics and these signal grounds. So if you can find a way to dissipate that noise, then you're just going to take off another layer of distortion and interference that kind of holds back the realistic reproduction, the dynamic reproduction of sound.
So Grant, you've got this new grounding product.
Mm-hmm.
But it seems to me there's some educational elements that have to fall into place. This is not, if you will, for lack of a better term, plug and play like with a power cord. It's pretty obvious what you do. You plug it into the wall, you connect it to the component. Mm-hmm. But with grounding, there are additional cables that have to be connected to different components in a certain way. There are different chassis that y'all have developed that all come together to play. How do you educate the consumer? How do you educate the dealer for this brave new world of grounding devices and even lower noise?
Well, people that get a good look at the grounding system and get a good look at the attending paperwork that we've developed for it, the explanations about the grounding concepts guide and everything that goes with it, we'll see that there's been 3 or 4 years of development here.
Okay,
and
good.
Our goal all along was to simplify the system, to make it so that people would be able, in a wide variety of systems, to achieve ease of application and consistency of results. So everything that we try to do, everything we explain, everything I demonstrate is intended to simplify the understanding of what these products are designed to do and how to best apply them in a specific system. So although there's a lot of attending paperwork that goes with them that we very much encourage everybody to read, before even considering an evaluation, just so they have a basic understanding. The reward is that once you've done that, the product is really exceedingly simple to install. I traveled just a week ago all through Germany, visiting a number of dealers and magazines, and at each stop we would do a quick demonstration. In a couple of places, you're somewhat time limited. It only took me 5-10 minutes to set this up. And the real beauty of this system is that once you've installed it, it's really simple to just unplug the cables that are connecting the hubs to the component, and the difference is quite immediate and quite striking. And so it's literally, the demonstration is over in the matter of 5 minutes. In most cases, we'd set up to do this fairly lengthy evaluation. I did this for 5 weeks prior to Germany in the United States, where I traveled all over the East Coast with this product. And usually it would just take a matter of seconds. Once the product was in and they heard what it contributed, and then I just took out the connections from the back of the Altairas, and immediately it was just like flipping a switch. So more so than power cords, more so than our power distributors, this probably makes the most discernible, fastest difference in a system that you're likely to hear from any other product that we make. And it makes a difference in systems that is unlike any other product that we make.
Okay, so you've got that. You're rolling it out to high-end audio.
Right.
Is the next frontier now going back out to these folks like Rick Rubin and James Guthrie and getting a grounding system to work in a recording studio?
I mean, these people are, like Rick, whose home I've been visiting off and on for more than 10 years. They're already sold. It's just a matter of them finding the time and the attention to spare to sit through an evaluation. So they're actually quite easy. It's the number of skeptics that are still out there that we have to win over, and we can first win them over just by explaining in very simple terms, in layman's terms, why these products are likely to have a profound effect on the reproduction of sound in their system. And if we buy enough of their confidence, we only need enough of their confidence to be allowed to have access to their system to set this up and play it. And the only thing you have to do prior to setting this up is just test the electronics for continuity to make sure that you've got continuity between the ground pin of a component and, let's say, a connection on the back of the component. Hopefully the component has a ground post, because that makes it really easy. But if it doesn't, there's also any chassis screw or any open RCA or XLR connection are also...
So we did the chassis screw on my audio research amplifier. That worked really well. That took it to a different level, I think, when we connected that.
Right, and the key takeaway is that it will do that in every system, on every component, every time, as long as you're following just the simple rules of making the connections to each hub. We have a 2-hub system, but I really only focused on using 1 hub to connect an entire system to that 1 hub so they could hear what that did. And then if they wanted, the second hub usually is brought in when you want to isolate, and that's what's really unique about this system. It's one of the key parts of this system that's really unique, is it allows you to separate, how I was always saying, separating noise-producing components away from, the analog or signal-sensitive components.
Yep.
Whether that be in medical, recording, or high-end audio, the objective is the same, is to isolate different disparate parts of the system kind of on their own island. And the grounding system follows that same logic. You're just trying to isolate away the noisiest parts of your system. So if you bring in a second hub, you'd connect all your big noise producers, which are typically your digital electronics, clocks, upsamplers, transports, servers, streamers, anything that's outputting a digital signal, ideally you want to isolate it on its own bank of ground posts, because each post on the back of the Altaira has its own dedicated filter set that's going to help isolate and protect that noise from leaking into other parts of the system and interfering with other components' ability to reproduce distortion-free signals. So, but the single hub is all I really started out demonstrating, and that's what won hearts and minds, because it was a simple demonstration. You just connect each component to a post on the back of it. You wait 10 seconds, you play a track, and you watch the reaction. And
but you've told me that even with the second hub, you can put the digital on it and maybe separate out the digital components, and that takes it to another level still? Yes,
it absolutely cuts the noise floor in terms of, if you're speaking subjectively, by another 30 to 40%. Of the perceived noise level in the system. There's going to be some variability depending on how big the system is, how many components are in the system.
Sure.
But keep in mind, 3 times I did this demonstration in the U.S., Goodwin's, JS Audio, Overture, we were doing 2-component systems in some cases. So there was just an integrated amp. In one example, they had a Griffin Audio integrated amp, a very high-end, high-performance integrated amp, and then they had a DCS Rossini server. And so I was just connecting those 2 components to the chassis hub, and immediately they heard a difference. And then just for fun, I said, well, why don't we just put the Rossini server player on that separate hub just to see what kind of difference that makes. And of course, that really won hearts and minds at that point. They were convinced at the efficacy of the system once they heard that. And everywhere I've been, every dealer I've been to, every review magazine in Germany that I visited, it was just snap your fingers and go. Whereas with power chords and sometimes power distributors, it'll take, a day, 2 days, and these do improve. I mean, whatever you hear initially, if you wait 24 hours, you'll get about 30, 40, 50% more performance after this has had time to settle into the system. But in my travels, I haven't had to do that.
And then one final question, and tell me if this is something you can answer, but obviously there's been a lot of buzz in the marketplace about the Omega digital cables. A lot of our reviewers have found them to be effective, but we've been wondering when are the analog signal cables coming out? Can you speak to that already?
Well, I'd say we're in the very final stage before release of the Omega interconnects and speaker cables. We've done about 2 years worth of prototyping with them, comparing them to other things in the marketplace, and testing them against our own products as well. And then the rest of it was just waiting for final pieces and parts, and I think we're just about ready.
Okay.
So within the next couple of months.
Great. Grant, thank you for your time, and thanks for letting us see the factory. It's very impressive. It's a bigger scale than I had anticipated, and the listening rooms have been fantastic, but the hospitality here has been the best part of it.
Well, we love having guests, so we love the opportunity to have you guys visit and learn a little bit more about our quirky little family and how we operate. So thanks for visiting.
Appreciate it.